Number 8 from paper 2 of the 2016 new hire. Here we go, there's the wave function. Two parts are back again. First part, change these two terms into a single term to facilitate the solution of this equation in part B. Well, the first part for 4 marks is change that into this form. Notice A, apart from telling you it's radians, doesn't give you any clue at all about A. That virtually says A could be anything. So expanding this, that would be k times, that'll be cos x cos A, but minus sine x sine A. I think I'll just take time to specify exactly what the coefficient is. The k cos A is the coefficient of cos x, and the k sine A is the coefficient of sine x. So now you can compare corresponding coefficients, so that the cos gives you k cos A is 5, and for the sine x you've got negative negative, so that's handy, so you've got k sine A is 2. And then combine them, for good reason. So if you do 1 squared plus 2 squared, you'll end up with k squared equals 2 squared plus 5 squared. So that k is going to be the square root of 4 plus 25, so that k is going to be the square root of 29. Well, and then if you do 1 divided by 2, you'll have tan of A equals 2/5. So the angle will be the inverse tan of 2/5. But the sine is positive, the cosine is positive, so it is in fact in the first quadrant. So whatever your calculator gives you will be the answer, but it is in radians. So just set your calculator radians and do it. And that comes up as 0.3805 and so on, and a bit. So that means I'm going to use A equals 0.381. And then putting it all together, that means you've got root 29 cos of x plus 0.381. Now in part B, there's a diagram that says, this shows a sketch of part of the graph of 10 plus this expression and the line y equals 12. They intersect at P and Q, and you have to find just the x coordinates of P and Q. We know the y coordinates are 12 anyway, for 4 marks. Well, I'll make the obvious statement first of all. At the points of intersection, these two must give the same answer. So I should say 10 plus 5 cos x minus 2 sine x should equal 12. And the whole point of part A was, I can now replace this part with this. So I've got 10 plus root 29 cos x plus 0.381 should equal 12. Now you're down to just a single mention of x, so you just peel it away. So root 29, I could have done 2 steps in one there, or maybe I should have done. That'll equal 12, take away 10, which is 2. I should have done 2 steps there as well. So that means it equals 2 over root 29. I could just have gone straight in with the inverse cos there. Too late. So that means it will be, getting rid of the cos, inverse cos of 2 over root 29. Now I'll have to find this, and of course there'll be 2 values, but I'm going to stick with radians. So in radians, I get 1.1902 and so on. It's a positive cosine, so it's either in the first or quadrants, which means the answers are 1.190, we'll say, or the other one would be short of 2 pi, so you'd have to do 2 pi minus it. Maybe I'll put the working down. 2 pi minus 1.190, which is 5.093. Now the final step is to take that across and subtract it, but maybe I'll just show that. 190 minus 0.381, the other one is 5.093 minus 0.381. So this one gives you 0.809, and this one gives you 4.712. Then the final part, it does say find the x coordinates of P and Q. So I'd have to specify which is which, even though they're written there, so I'll write it down this way. X of P is 0.809 and X of Q is 4.712. Of course, you may have done it all in degrees, as long as you change it back into radians for your answer before you put this in, and at the end here before you put these in as your final answer.